Hi guys, in this video we are going to work with circle geometry grade 11. So specifically we are going to look at a center theorem that states angles in a semicircle. Right, without wasting time, let's see what this theorem states. Right, the theorem states that the angle subtended at the circle by a diameter is a right angle. It states the angle subtended at the circle by a diameter is a right angle. Okay, so let's consider a proof first. We'll first dwell on a proof first. Okay, let's draw okay, we have let's draw the diameter first. Here's the diameter. Okay, let's try to go. Yeah, yours will be accurate because you will use a ruler there. So yours will be just accurate. Okay, we have something like this. Center O there. Then let's say it's A here. And let's say it's B. And let's say it's C here. So consider that we are given circle with a diameter AOB, right? RTP we are required to prove that angle C is equals to 90 degrees. Okay, right. When we are required to prove, that C is equals to 90 degrees. In this case, we don't need to construct anything. And guys, another thing is that you won't be asked to prove this in an examination. I'm just doing this for curiosity and for enrichment, right? So let's this is proof. Okay. So we are required to prove that angle C is 90 degrees. Remember what I told you about the theorem. It states that the angle subtended at the circle by a diameter, it's a right angle. And we know that the right angle should be 90 degrees, isn't it? So consider this. When you prove that, we can see that angle AOB is twice at C. We know the reason. Angle at the center is twice the angle at the circumference. So this will be the reason. Angle at the center is twice the angle at the circumference. Angle at the center is twice the angle at the circumference. Okay. Another thing, we can see that angle AOB is equals to 180. We know those are angles in a straight line. Straight line there. Straight line, therefore since it's equals to 180, let's go back upward there. We said that AOB is twice C, so where we see AOB we replace by 180. So we are going to say 180 is equals to 2 is twice there. Okay, so equals to 2C. Then to make C the subject, we make angle C, we divide by 2. So for that, therefore angle C will be 90 degrees. Then hence it's proven. Okay, so the reason, whenever you're working with this type of theorem, always write angle in a semicircle. So this is what you're going to do. So let's work on the questions now. Let's work on the questions. Right, let's work out the questions. All right, we'll look at these two examples there so that we apply this theorem. Calculate the value of the unknown variables. Right, let's say maybe there was a missing value there of x. There was a missing value of x there. So first thing first, guys, we can see that there's a diameter. A diameter subtends an angle at 90 degrees. The angle subtended at the circle by diameter, it's a right angle. So don't forget that here in this case, we can see that C will be what? C will be equal to 90 degrees. Reason, angle in a semicircle. So that's the reason. The statement is that angle C is equals to angle C, it seems as O. Angle C is equals to 90 degrees, right? Okay, so we could see that this is 90 degrees. So we need to find the missing value there, the missing value, which is x, which is our A. How do we get our A? We can see that x there, it's an angle on a triangle, or sum of angles on a triangle. So what we could do, it's adding these two angles. We will sum up 90 plus 60 there. We can see that it gives us 150 equated to 180. So we can make x the subject by transposing 150 to the other side. 180 minus 150, that gives us 30 degrees. So the reason, angles on a triangle. So that's the reason behind this. Okay, all right, we can see what happened there. Let's go to our last question actually. Right, let's go to our last question. We are looking for the value of the unknown variable, which is x in this case. What you could see, that is a diameter. So here it forms 90 degrees at R. So at R, it will be 90 degrees. So to get x, we are going to say x plus 42 equated to 90. So you make x the subject by transposing 90 to the other side. 90 minus 42, that will give us 48. So in other words, when we said 42 plus 48, we are going to get a 90. So the reason here, it's going to be angle in a semicircle. Angles in a semicircle. So why are we saying that x is equals to 48? What is the reason? The reason is that as you can see that the OR Q will be equals to 42. The reason is just because of OR Q is 42 degrees. It is because of this angle. So that's the reason why we are getting 48 here. So, and both of these angles, when we add them, they will give us 90. So when they ask you a reason, you should write it like this. So this is how, guys, you can work out angles in a semicircle. Center theorem. Actually, this is our last video of center theorem. Next week we are going to dwell with we are going to work with what we call cyclic quads. You're going to work with cyclic quads. See you on the next video, which will be about cyclic quads. Don't forget to like the video and share the video and subscribe if you are new to this channel. You only subscribe once, and remember, we love you.